This is 2.2 vectors, scalars, and coordinate system. Figure 2.6. The motion of the eclipse concept jet can be described in terms of the distance it has traveled, a scalar quantity, or its displacement in a specific direction, a vector quantity. In order to specify the direction of motion, this displacement must be described based on a coordinate system. In this case, it may be convenient to choose motion toward the left as positive motion. It is the forward direction of the plane, although in many cases the x-coordinate runs from left to right, with motion to the right as positive and motion to the left as negative. What is the difference between distance and displacement? Whereas displacement is defined by both direction and magnitude, distance is defined only by magnitude. Displacement is an example of vector quantity. Distance is an example of scalar quantity. A vector is any quantity with both magnitude and direction. Other examples of vectors include a velocity of 90 kilometers per hour east and a force of 500 newtons straight down. The direction of one-dimensional motion is given simply by a plus or a minus sign. Vectors are represented graphically by arrows. An arrow used to present a vector has a length proportional to the vector's magnitude. Example, the larger the magnitude, the longer the length of a vector, and points in the same direction as the vector. Some physical quantities, like distance, either have no direction or none is specified. A scalar is a quantity that has a magnitude but no direction. For example, a 20 degrees Celsius temperature, the 250 kilocalories, 250 calories of energy in a candy bar, a 90 kilometer per hour speed limit, a person's 1.8 meter height, and a distance of 2.0 meters are all scalars, quantities with no specified direction. Note, however, that a scalar can be negative, such as a negative 20 degrees Celsius temperature. In this case, the minus sign indicates a point on a scale rather than a direction. Scalars are never represented by arrows. Coordinate system for one-dimensional motion. In order to describe the direction of a vector quantity, you must designate a coordinate system within a reference frame. For one-dimensional motion, this is a simple coordinate system consisting of a one-dimensional coordinate line. In general, when describing horizontal motion, motion to the right is usually considered positive and motion to the left is considered negative. With vertical motion, motion up is usually positive and motion down is negative. In some cases, however, as with the jet in figure 2.6, it can be more convenient to switch the positive and negative directions. For example, if you were analyzing the motion of falling objects, it can be useful to define downwards as a positive direction. If people in a race are running to the left, it is useful to define left as a positive direction. It does not matter as long as the system is clear and consistent. Once you assign a positive direction and start solving a problem, you cannot change it. Figure 2.7. It is usually convenient to consider the motion upward or to the right as positive and motion downward or to the left as negative.